Hello and welcome. Let's take a look at today's lesson for Algebra 1, Lesson 5.6 on the slope-intercept form. Our objectives for today are to understand what slope-intercept form represents, to write a linear equation in slope-intercept form, to graph a line using the slope-intercept form. So first of all, slope-intercept form of a linear equation is represented by the following equation: y equals mx plus b. And as you can see, when we look at y equals mx plus b, we can look at this a couple different ways. Number one is that our m is always represented by our slope. And as we've talked about in the past, the slope is represented by the rise over run, or the change in y over the change in x. And b is going to represent our y-intercept, or the spot in which our graph, or our equation, or our line crosses the y-axis. So for what we're doing for this lesson, this equation is going to be very useful in understanding the parts and the components of it. Let's take a look at this example. They want us to graph using the slope and the y-intercept. So right away we know that we have a slope of 2 and a y-intercept of -3. So that's telling us is our y-intercept is going to cross the y-axis at -3. So if I come down here, 1, 2, 3, and I put a mark, I know that that's where it's going to cross. Now the next thing I need to identify is what the slope is, and we are told, we're given that it's 2. So that's 2 over 1. So that means I'm going to go over 1 and up 2. Over 1 and up 2. And again, I'm going to repeat this pattern. And I can see, so we can see that it's going to cross through these points with our line. So if I were to go ahead and draw a line through these points, like so, that's going to be a graph that represents a slope of 2. It crosses at -3, our y-intercept. If I look at the second example here, I've got a y-intercept of 1. So that means it's going to cross right here on the y-axis. And I've got a -2/3 for my slope, which means I'm going to go over 3 and down 2 this time because it's negative. So again, I'm going to repeat this pattern: over 3 and down 2, over 3 and down 2. I'm going to do the same thing. I can do it in the opposite direction, over 3, to continue the pattern. And then again, I'm going to draw a line that's going to go through these points. So when we're given the slope and we're given the y-intercept and we're asked to graph, the steps are pretty straightforward. We're going to first identify where it crosses the y-axis, mark that point, and then from there, that's our starting point for identifying the slope, and we're going to change the rise over the run in whatever the format that they've given us, if it's a negative or if it's a positive, and whatever the slope for the value that is given. In our next example, we have how to write linear equations based on the slope and the y-intercept. So in this case, we are given the slope and we are given the y-intercept of 6. So we know that our equation is y equals mx plus b. So in this case, we know that our slope is 1/3, so we're going to substitute 1/3 in for the m, and we know that our y-intercept is 6. So I can rewrite the equation as y equals 1/3 of x plus 6. And in this case, I've written a linear equation in slope-intercept form, because that's the important part, which is y equals mx plus b. And all I've had to do is substitute the values that are given. So the slope of 1/3, so that means I'm going to change my m value for the slope, and I'm going to change my b value for the y-intercept. Again, if I look at this next example, I have a slope of -12. I have a y-intercept this time of -1/2. I'm still going to use the same equation, y equals mx plus b. So in this case, I'm going to substitute my slope for negative 12. So I'm going to get a negative 12, and then I'm going to substitute my y-intercept for a minus 1/2. So when I finish my equation, I end up with y equals a negative 12x minus 1/2 in this case. So I can rewrite it, y equals negative 12x minus 1/2, and now I have the linear equation written in slope-intercept form based on the given negative 12 and negative 1/2. So when writing, if we're told what the slope and the y-intercept is, it becomes just being able to substitute those values into the correct positions. In this example, we have a line that they're telling us it has a slope of 8 and now goes to the coordinates 3 and negative 1. They want us to write an equation that describes this line in slope-intercept form. So right away, we need to remember that we have y equals mx plus b. Probably getting sick of hearing that. But now we're given the slope, so we know that we're going to have y equals 8x plus b. And what else do we know? In this case, we know what the x value is, and we know what the y value is. So we're going to substitute what we know into this equation. We're going to say that the y value is negative 1, our slope is 8, our x value is 3, and what we don't know is what b is, or our y-intercept. So now we're just going to solve for b. So 8 times 3 equals 24. So 24 plus b equals negative 1. We're going to subtract 24 from this side, subtract 24 from this side, and we get negative 25 equals b. Once we have that, we can now write this equation in slope-intercept form. We can go back to our beginning and say that here's our slope of 8, and here's now our y-intercept of negative 25. So y equals 8x minus 25. And if I've done it correctly, I should be able to plug in my 3 and my negative 1 and solve it, and it should make the statement true. So if I plugged in a negative 1 here, if I plugged in a 3 for x, minus 25, so then when I solve this, it should make the statement true. So 24 minus 25, that does equal negative 1. So negative 1 equals negative 1, so it's true. It checks. So again, we have to identify what do we know, and then how do we substitute those values into our slope-intercept form, our equation, and then solve for what we're missing for, which in this case was the y-intercept, or b. In these final examples, we're going to use the slope-intercept form to graph. And again, we know at this point our slope-intercept form is represented by y equals mx plus b. And in this case, we have y equals 2/3 x, but there's no b, so it's the same as saying plus 0. And that means it's going to go through the origin. So we can use the slope as 2/3, and we can go ahead and say 1, 2, 3 over, and 2 up. 1, 2, 3 over, and 2 up. And we're going to see the points that we are going to need on our graph in order to graph our line. So we're using the same information that we were given to identify and write our information on our graph using the slope-intercept form. In the second example here, now we're given it in terms of a standard form. So we have to solve for y. That's the very first step we have to do, is solve for y. If we solve for y, it'll automatically go into slope-intercept form. So in this case, we want to subtract 6x from each side. So let's go through and do this. 2y equals 10. I'm going to subtract 6x. And then we're left with 2y equals a negative 6x plus 10. And we're going to need to divide everything by 2. And I'm going to be left with y equals negative 3x plus 5. And now it's in slope-intercept form. So I can start at plus 5. So 1, 2, 3, 4, 5. And my slope is going to be a negative 3. So 1 over and 3 down. 1 over, 3 down. And now I can go ahead and connect those through those points and see the graph of the line. The last example we have, y equals negative 4. So in this case, we don't have an x value. So if we don't have an x value, that means that we have a 0 slope. If there is no x value, the slope is 0. Slope equals 0. So if our slope is 0, then we're going to go down here to negative 4. That means that that's where it's crossing. That's our y-intercept. And we are going to have a line with 0 slope that crosses through negative 4. So basically we're just going to have that horizontal line that is going to cross right there through our point on the graph. I need to move that up a little bit. And there it goes. So we have a line that's going to cross right through negative 4. So those are some ways that we can use it based on a standard form and some of the equations. That the number one rule there is that we have to get y by itself. When we get y by itself, we're able to solve, and then we can reorder it into slope-intercept form in order to graph, make things easier for ourselves to graph. Hopefully that'll help you out for lesson 5-6, and we'll move on from there in class.